Now I'm just quickly going to show you this experiment because it's popular among some teachers, and it's even in some IB exams. So it comes from about 40 years ago, and I think because our technology is a lot better now, probably should do away with it, to be honest. And so what it is basically you just add volume of acid continually past the equivalence point and measure the temperature as you go. And then you basically have to draw two lines of best fit to try and work out where the highest temperature point is and the correct volume of acid. So I've tried to replicate that here, and so I've got a temperature data logger and I've got a drop counter so I know exactly how much liquid is in there. So just like the previous one, so the previous one was doing it the normal way where you just all dump it in and the data logger tells you where the temperature is, and if it drops you extrapolate back. And so I've just done the same thing here, except for I've told the data logger here just take readings every 10 seconds. And then we'll just empty in a certain amount of volume, and so we'll get the same sort of data. We'll get every 10 seconds we'll get a temperature and a volume reading. And so when I process that data there, I end up getting a little confused about whether I should take this line or that line. That one's clearly curving over. And so I've come up with 21. So obviously the correct answer is meant to be 25 because it was 1 molar sodium hydroxide, 1 molar HCl, and 25 was initially in the cup. And so it's kind of way off, and that's why I never really liked it, because you never know how high it's going. So just to put this line in here, you never really let it reach its highest temperature, and it's constantly cooling, and you can see it cooling on this angle here. And so even if I sort of just take the most extreme here, I still don't get anywhere near 25. You got to remember the previous method got to like 1% error or less than 1% error, and that's just doing it very roughly first time, like this one here. And so you can see that there's a huge systematic error here in not letting it reach its highest temperature, and that could perhaps get us to the correct number, which is 25. So I have to throw this one in here. It's a little bit like a job mix between a jobs plot and a standard enthalpy experiment, where you just dump it all in there and then see it rise up, because it's popping up in exams. So you kind of have to know what they're doing. Okay.